This video will cover measuring your piston rings, your wrist pin, and the pin bearing on page 4 of your packet. The components you'll need to measure the piston rings include your cylinder, your rings, and your piston. The only tool you'll need to complete the first part of page 4 is a feeler gauge. Just like shown here in the video, your rings should already have been removed from your piston. If your rings have not been removed from your piston, refer back to the previous video to see how that is done. To measure piston ring end gap, I'll simply start by placing the open end of the ring into the cylinder bore first and then pressing in the other side. To get an accurate ring end gap measurement, we need to use the top of our piston to square up the ring in the cylinder bore. Now with the ring squared up in the cylinder bore, I'll simply take my feeler gauge and measure the ring end gap. When using a feeler gauge, I'm looking for that Goldilocks fit. I don't want a fit that's too loose, and I don't want to have to force the feeler gauge into the gap. I want to find one that fits perfectly, and that will be my measurement. Here is my measurement for compression ring number 1. I am now going to remove compression ring number 1 from my cylinder bore, and then measure compression ring number 2 and the oil control ring just like I did compression ring number 1. Here is my ring end gap measurement for compression ring number 2. I'll now remove compression ring number 2 so that I can measure the oil control ring. Here's my ring end gap measurement for the oil control ring. Now with our ring end gaps measured, we'll now measure the ring side clearance. For this, we'll need our piston, the rings, and a feeler gauge. To measure the ring side clearance, simply take the ring and place it into the piston groove that you removed it from. Then place a feeler gauge in between the gap to see how much clearance there is. You'll then compare your measurement to your specifications to tell if the ring groove on your pistons are within specifications or not. Here is my measurement for compression ring number 1. I will complete the same steps again for compression ring number 2 and my oil control ring. This is the feeler gauge that had the Goldilocks fit for compression ring number 2. If you have a 3-part oil control ring, we need to put all 3 parts of the oil ring into the ring groove. Because the 15/10,000ths feeler gauge did not fit between the ring and the ring groove, I'll write on my paper that this measurement was less than 15/10,000ths of an inch. Now that we have our piston rings measured, we now need to measure our wrist pin. To perform this measurement, we first need to remove the wrist pin from our piston and connecting rod. We'll use a needle nose pliers to remove this G-clip. With the retaining clip now removed, I'll simply tap the wrist pin out of the piston and connecting rod and place all my components in a plastic bag so I do not lose them. This step is the reason why we marked our piston head and the connecting rod before removing it from the cylinder bore, so that way when we reinstall our piston into our cylinder, we know how to properly reinstall it. With the wrist pin now removed from our piston and connecting rod, we can now perform our measurements. We'll now measure each end of the wrist pin twice, like shown in the illustration, to see if our wrist pin is out or round. To complete this task, we'll simply need our wrist pin and the appropriate size micrometer. Because of the size of my wrist pin in the bore, for all my measurements I used a 0 to 1 inch micrometer. Here is my measurement for A1. Here is what I measured for A2. This was my B1 measurement. Here is my final wrist pin measurement. Using your numbers from side A and side B, you'll now calculate the outer round and average for each side. Now that I have my wrist pin measured, it is time to measure the bearings located in the piston. Pay attention as you make these measurements. If your pin bearings are smaller than your wrist pin, there is something wrong with your measurements. Tools you may need to complete this part of your packet include a micrometer, a small hole gauge, a telescoping gauge, and your piston. Measuring the pin bearing is just like when we measure the cylinder bore. We'll select the right size telescoping gauge or small hole gauge that fits perfectly inside the wrist pin bearing. Here's the pin bearing measurement for A1. Just like how we measure the wrist pin, we'll also measure the bearing in two different directions so we can compare the numbers. Here is my A2 measurement. Here's what I measured for B1. Lastly, here's my B2 measurement. Just like we did with the wrist pin, now we need to find the average diameter for each side and the outer round. Remember, we calculate outer round by subtracting A1 from A2 and then B1 from B2. To find your answer for average clearance end A and B, you'll simply take your pin bearing measurement average and subtract your wrist pin average from it. You should now have completed all of page 4 for your small engine reconditioning packet.